Welcome back to the channel, everyone. So I wanted to bring this topic back up. I went over this last year, fairly early last year, right around this time last year. And this is about Intel's oxidation and their CPUs degrading, and one of the majority factors causing these CPUs to degrade quick. And it was not Intel's fault on that. A lot of people won't believe me on this, but it was true. Everything was true that I said last year. Everything that I gathered up from last year, it came out to be true. And a lot of content creators, like Jay's 2 Cent, was one of the first ones to put it out there. I guess I was one of the first ones to put it out there. But about 4 or 5 months down the road, Jay's 2 Cents put it out there that it was motherboard manufacturers causing these issues with the voltages being way too high on stock settings. So we're going to go over his video again. I'm going to make a little bit more detailed video about this. I did do a live stream about this, and we're going to go through this and see, and I'm going to tell you all. I'm going to tell you all everything about it and what Intel implemented into their new CPUs, what they should have done a while ago so that this did not happen.
A special message from iFixit. Yo, we interrupt this interruption with this interruption about new stuff from iFixit.
His intros are awesome for these.
Fix the inventory problems with iFixit. Whoa, don't drop it. Can't fix that with iFixit. Just kidding, yes you can. Wish you could take iFixit with you anywhere.
Okay.
The pockets aren't big enough.
Gen failures.
More explosions. Even more explosions. Why are you still here? Click the description now.
So on a high level, one of the reasons why 13th and 14th gen failures were so prevalent, really widespread, is because of the fact that board partners or board vendors like Gigabyte, Asus, MSI, ASRock, they all basically got to like free reign, do whatever they want. Even though...
Now what he's saying here is that on stock settings, this is for stock settings on motherboards. Again, motherboard manufacturers had a lot of leniency and leadway on what they could do to Intel CPUs to get the best for their motherboards, to make sure everything's stable on Intel motherboards, not just for the CPU, but also for the RAM as well. And again, like when he says, and again, when I said before, is they had a lot of freedom. They had a ton of freedom. They were allowed to do whatever they wanted so that when their motherboard was the best of the best. So Asus, Gigabyte, every kind of motherboard manufacturers out there like that. Asus was one of the worst ones for it, though. But this is it. This is what we need to go over again, just to tell you, the consumer and people, that it was not just Intel's fault on this. It was motherboard manufacturers, and Intel took the blame. Took a big blame for this.
Fiber existed, which is the fully integrated voltage regulator, which was on chip, the motherboard could still command the CPU to do things outside of the CPU.
So right there, what he's talking about would be the voltage request, or the VID. So the VID is the voltage requested, and that is right there is put in place by motherboard manufacturers. The CPU does not need certain voltages to be stable. Again, motherboard manufacturers wanted to have the best stable and or best overclockability on their motherboards, so the VID would be a lot higher than what it should be on stock settings.
You requesting things. So there was a request, and then there was a demand, and the motherboard could override those requests from the CPU and push voltages and stuff to whatever power profiles and such that the board partners and the board vendors wanted to do. And this competition took place amongst the board vendors, because if your board had like secret sauce settings that would make your CPU faster in their board than, say, another brand.
So let's say they had like max performance mode, or they had 6 gigahertz overclock mode, or something like that. That was also due to the fact that's the motherboard manufacturer. That wasn't for the Intel CPU. It was motherboard manufacturers put in place their own voltages to get these frequencies out of the CPUs, whatever voltage they wanted, to make sure it was stable, basically, to get this 6 gigahertz overclock, or all-core overclock, whatever they had in place on their motherboards at the time. It has completely changed with all these updates on the BIOSes and that. That's where microcode update was also implemented as well. And they put way too much voltages.
It became another level of competition taking place outside of just what the CPU performance itself could do. Unfortunately, Intel did not do a very good job at reining in and putting kind of restrictions in place.
Nor did they even know why their CPUs were degrading at the time. Crazy how Intel didn't even know that these motherboard manufacturers were putting these parameters in place and way overvolting their CPUs to the point where the CPUs were degrading within either weeks or months or within a year. Their CPUs were degrading, and Intel didn't know that the motherboard manufacturers had these in place. So that right there just tells you that Intel wasn't really looking at motherboard manufacturers at the time and going, okay, well, maybe motherboard manufacturers are doing something here, maybe going past the parameters we gave them. And they didn't have any kind of like lockdown for motherboard manufacturers at the time, saying you can only use this much voltages or you can only use these kind of parameters. You're only allowed to use this. No, they gave motherboard manufacturers the freedom that they thought that they'd be fine with, and they just went way up and past and beyond what the actual specs of these CPUs should have been put in place.
On how far these board partners could push the CPUs. Also, too, because they're case SKUs and they're fully unlocked, the board vendors could do whatever the heck they want. So high level, board partners or board vendors started pushing voltages higher and higher to get more stability because they were putting no limits in place when it comes to how far
Before we go any further, that's also for RAM manufacturers with their XMP. Just put way too much voltages into the actual SA voltage. I've gone through this with stabilizing Intel's and 13th and 14th gen CPUs. That with the XMP, they're putting over 1.3 volts to get 7200 mega transfer stable. Let's say that. You don't need 1.3 or 1.35 volts on the actual SA voltage to get the RAM stable. I've shown this multiple times, multiple videos now, that you can use 1.2 or 1.25 volts, which is way less voltages on the actual SA for the RAM. So the SA voltage 1.25 volts is more than enough to get this 7200 or even 7600 mega transfers per second stable. And they're implementing 1.3 to 1.35 volts on the SA voltage, which is absolutely insane in my opinion. And that there can actually degrade the CPU side, which is crazy. Crazy how not just motherboard manufacturers, but also RAM manufacturers were putting these voltages in and actually degrading CPUs this way as well.
voltages and stuff could go. So in order to try and push the clock speeds and get as much stability as possible, they just brute forced it with a ton of voltage. And what was actually killing the CPUs was not all core voltages or all core workloads. It was actually single core and two core workloads, because in those conditions, those cores could go to.
So you got all core, which is, let's say 13900K. It's 5.5 gigahertz on all core. And then it'll go up from there. And then onto two cores, it'll be 5.8 gigahertz. And the voltages could go up from there, or generally does go up from there. So if you're on two cores and it goes to 5.8 gigahertz, the voltages from, let's say they're doing all core 1.5 volts on all core, 1.5 volts to 5.5 gigahertz on all of the P cores. Even if it's on the P cores, it'll still hit the E cores as well, because it does not have the new parameter that Intel has in place on the new CPUs. Intel 13th, 12th, 13th, and 14th gens don't have this new DLVR put in place. So we'll go over that as well. But let's say it goes from 5.5 gigahertz all core, 1.5 volts, and then it goes to the two core. All of a sudden it just goes to core. It doesn't need all core running again. Goes to two core. The voltages will go up to like 1.6 volts or above 1.6 volts, just to get the 5.8 gigahertz stable on 2 cores. That's it. That's all it needs, right? That's all it's using. And then all of a sudden the voltages go up. It does not need that kind of voltage to be stable either. Like, I've gone through this as well.
The highest clocks that were set, which was 6 gigahertz and above sometimes, which meant big spikes of voltage to those particular cores. So it was actually those types of situations that were killing the CPUs when it came to voltages, not all core workloads. Because under all core workloads in V-Droop, it was actually lower voltage and lower frequency.
And I've gone through this as well with the V-Droop. So the V-Droop on the 13th, 14th gen, it really likes a droopy. It likes your load line to be quite droopy. So it might use higher voltage at one point, but then while it's running in that, the voltages will start dropping down on it. So from, like, let's say 1.5 all the way down to 1.4 volts or even lower, it will just automatically drop. And this is where putting in these kind of parameters in place into the actual BIOS, and I've shown how to do this into the load line calibration, is that you can set the load line, instead of it being like extreme or something like that, where it might actually be set at that, you can just set it to high and now put it to a nice droopy load line, and it will make sure the voltages drop down, which will actually help save your CPU and make it actually more stable, which is actually crazy.
Frequencies across the board. So now that you understand that, we're going to talk about DLVR, which stands for Digital Linear Voltage Regulator. So
DLVR, Digital Linear Voltage Regulator, is not in place with the 13th and 14th or even 12th gen CPUs. It was put in place kind of way back where you can put different voltages in each core. So each core can have a different voltage. And that was more or less for like dual core or even 4-core CPUs, but it hasn't been in place for a very long time. And 13th, 14th gen they don't have that either. So you put 1.5 volts into the P cores, you're going to get 1.5 volts into the E cores as well. And the E cores technically don't need that kind of voltage.
It's the next evolution of Fiverr, if you will. DLVR has a few really interesting design elements in there. And the cool thing about DLVR, at least where Intel is concerned, is the board vendors are no longer allowed, period, to ship a board with a BIOS that has anything other than the Intel performance mode defaults enabled. Now, that's the way that the BIOS were supposed to be after the fixes for 13th and 14th gen. But I think, as we covered and other people have covered,
on Gigabyte boards, they'll ship it as extreme mode. Or extreme mode. It's not extreme at all. It is Intel's parameters that they have in place, and it's just called extreme mode. Then you can also put it to max performance mode as well, which will keep it also in Intel specs. Then you can disable this as well, and then you can put in your own voltages and do whatever you want. It's just whatever you want. You can go way up and past 1.6 volts onto that. But if you're on max performance or extreme mode, it won't hit these kind of voltages, even though it will go quite high. Like, I've seen 1.55 volts. I mean, I've seen 1.55 volts on the vid, which is way more than what it needs. The CPU might not actually get that voltage, but if the vid's requesting it, then the CPU can technically get that voltage.
It took several BIOS iterations before the board vendors really got on board with truly following the Intel power profiles out of the box. So for instance, like our Asus board for a while there, sure, they put the Intel power profiles in there, but it was really kind of a convoluted 2-step process to get them activated, where they would still ship with their 4096 watts and whatever ridiculous unlimited settings.
Unlimited. So basically on auto, so on stock settings, it was allowing the CPU to hit the overclock, like extreme overclock parameters, which is 511 amps and or hit 4096 watts. It will never hit 4096 watts, of course, but it'll allow it to use that kind of parameter, which there are multiple different kind of parameters for CPUs, and hitting the 511 and 496 watt parameter is the max parameter, basically for us overclockers, us extreme overclockers. We don't want to have any kind of limits. We want the motherboard to be able to give the CPU whatever we want it, so that way we can get stable voltages up past 7 gigahertz. Or if you have not checked it out, MR Labs did a 14900KS up to 9.1 gigahertz.
is enabled. Now, if everyone out there who has 13th and 14th gen and Z790, Z690 boards have updated their BIOS, they should now be Intel Performance Profile out of the box. Now, that is what's going to follow into Arrow Lake. And I had a one-on-one meeting with Intel, and I got to ask.
So the Ultra 9 285Ks are going to be using it. Now the Intel Ultra 9 200 series, you can put voltages on every core. You can change the voltages on every core. You don't have to worry about putting one voltage in and it goes on to every core, like the P cores and E cores. Now you can switch out the voltages for all the cores, which is absolutely amazing. Way better for if you're an overclocker, you can get way better temperatures out of it, and or better stability if you're trying to get a really high overclock.
Ask these questions because I was like, architecturally stuff aside, that's all cool. I'm really more interested in what the actual steps that were taken are to make sure that this doesn't happen again. So that's why the DLVR discussion really kind of took place. They are going to be overseeing every aspect of the board vendor. So there's going to be a much more stringent, much more...
I've gone through this before. Intel will be overseeing their motherboard partners much more stringently. Yeah, they will be. And instead of having one motherboard vendor being better for their CPUs, now the motherboard vendors will have in place basically the same parameters and only allowed to go to the same parameters, which means it doesn't really matter which motherboard manufacturer you go to now. It will perform the same, and you won't have to worry about your CPU degrading due to the fact you're going to ASUS, let's say, because ASUS was one of the worst ones. ASUS was putting 1.6 volts into the CPU in the BIOS when it should have been 1 volt, maybe 1 volt. It was using 1.6 volts in the BIOS. So if you're tuning your CPU in the BIOS, tuning the RAM, let's say, or even updating your BIOS like that's all you're doing is updating the BIOS. You're going to the BIOS so you can update it. It's using 1.6 volts. For what? You're in the BIOS. You don't need 1.6 volts. Like, it's absolutely insane what ASUS or ASUS, what I like to call them, was doing. ASUS makes great GPUs and motherboards and that, but for these CPUs, they were putting in 1.6 volts, which is absolutely crazy.
Official kind of an audit process taking place to make sure that the board vendors are not creating problems for consumers by having the CPUs operate outside of their expected power profiles. Now, the power profiles are the same 3 names, which we kind of talked about is kind of, we don't like it because of the fact that it creates confusion. But there's the Intel baseline profile. There's
a lot of confusion. Again, Gigabyte on stock, just stock, like with the newest, latest BIOS. It's called Extreme, and then you got Max Performance, and then you get to disable that and put in whatever you want. You can do the manual tuning. It'll tell you that it can void warranties and stuff like this if you disable it, but it's Extreme on the stock, and then you got also Max Performance, which will give it a little bit more juice, basically.
There's the Intel Performance Profile, and then there's the Intel Extreme Profile. Now, the Extreme Profile is basically where the amperage, the watts, the volts, and all of that is set to the max rated limit for the CPU. Should basically never exceed those limits no matter what, unless you're doing like LN2 world record overclock.
Exactly.
We'll talk
for
about
us
that
overclockers.
But just like fiber, you can actually drill down into through the voltage power gates. You can actually drill down into individual voltage control per P core. So depending on how many P cores are on the chip that you get, there's 3 core Ultra CPUs that are launching, right? The 285, 265, 245 K, and then they are going to have different P core, E core counts. So each P core can have its own voltage control and its own frequency control, which is kind of nice, like the VF curve on a per P core basis. That's just like how fiber was. And just like fiber, it's going to have your CPU degrade to the point to where it's no longer stable. Usually under regular use case scenarios for like gamers and stuff that aren't overclocking anything would never ever see their CPU degrade to the point to where it's no longer stable in its lifespan that you would have it be relevant and usable. That's why you see people with 10, 15-year-old systems that are still running. Every piece of
15-year-old CPU still runs like new.
Great. And the problem with the issues that we talked about was it definitely accelerated the rate at which that degradation was happening. So I asked him, I said, how are you guys testing this to even try and head off any of these problems at the start? Because if it's a degradation problem, it might take that year or 2 or 3 to find out what's happening.
And that's why they
doing
put,
right now is they're actually,
that's also why Intel stepped up and gave you an extra warranty or extended warranty on the CPUs. So that way, if you do have this issue, even though it could have been from the motherboard manufacturers, again, Intel just stepped up and said, we'll give you an extra warranty just in case your CPU is degraded or no longer working like it was before. That's absolutely amazing, in my opinion.
actually doing some testing.
Again, I had multiple of these CPUs, 13900K and 13900KF, from the actual oxidized CPU bin. I saw no issues from that CPU whatsoever. Only because I overclocked it from as soon as I get it. As soon as I get it, I overclocked it. I check the voltages, I check everything, and I set the overclock to how I would like it, and I set the voltages how I would want it. So that way, I was happy with how cool it was running, and or it was running nice and stable for a lower voltage than what the actual motherboard was put in place. Because again, it's the motherboard that puts these voltages and all that in place. So I do all the overclocking. As soon as I get my CPUs, I overclock them to how I want. So same thing with RAM. Again, RAM was putting in too much voltages and that too. So even with like the RAM kits that I have, it was putting over 1.325 volts into the actual SA and putting 1.45 volts into the RAM, and I would just lower that and figure out what was stable, and I would do all the timings on the RAM to make sure I had better timings than what the XMP was. I didn't have to worry about instability either, and it's one of the reasons why I never saw an issue like this, because I did manual overclocking as soon as I got it, which a lot of people should learn about their CPUs and learn about overclocking, so that way if they see an issue or they know if there's an issue about their CPU, about how it might degrade over time just because you're actually looking at, well, these voltages just seem really high. I wonder if I can lower these and still be stable. And the thing is, you can. Most CPUs, and if not all CPUs, can be stable at lower voltages. Gaming and or benchmarking does not matter.
In some pretty harsh environments. They're actually using iCafes in mainland China, where they are running these desktops, not like servers, but desktops in extremely hot, cluttered, clustered, humid environments. So not only are they testing it with hot environment, they're testing it in high humidity environments as well.
It's also one of the reasons why when I'm doing my live streams and I'm getting people from all over the world, I'm wondering what kind of PC hardware they have, if they're using liquid cooled, air cooled, if they have AC, what kind of temperatures it's out there, and how well their CPUs and or GPUs are working, because I like to know these kind of things as well. It's just really good to know that their CPUs and or GPUs is performing correctly at no matter what temperature or humidity, because it's completely different all around the world.
And apparently these systems are running 24/7 in these labs. So I'm not sure how the humidity necessarily plays into the potential degradation.
So humidity can put in place because having some sort of moisture or more humidity in the air will actually help cool down air coolers and liquid coolers. That's just how it works. That's how thermal transfer and all that works. Thermodynamics. You have some sort of you spray. Okay, if you look at AC units, like window shakers, they have a tray where water will sit at the bottom, and then the fan in the back will splash some of this water on top of the fins. That will actually help cool down the actual radiator and make the actual AC unit perform better. And that is put in place for a reason. So if you see that your tray is filling up with water, don't drill a hole in it. The water's supposed to be there so that way the fan can kick on and spray some of the water on the radiator to help cool it down and make it perform better. Even way more efficient as well, because it will actually help cool it down better and actually chill the air that's going through it better.
But that's the environment in which they're testing them. And I guess that's important. You have to be able to support all regions of the world, and high humid areas like the Pacific, South Pacific, East Asia, they're very, very humid climate.
Yeah, go to here now.
Causing problems for people with it not functioning correctly. Now, OEMs and ODMs like Alienware, Dell, HP Omen, Lenovo, right, Acer, all these guys. So they've got in-house built systems that typically have their own custom BIOS loaded on these motherboards that may or may not be what looks like either proprietary or non-proprietary motherboards. They are actually being given some leeway on how far they want to push the voltages. Now, they can sort of kind of denote
more or less probably because they're getting really hot. You get a little bit more voltages. Voltage gets unstable as temperatures rise.
I think the reason why Intel is allowing that versus board vendors is when you buy a box CPU and you put it in a motherboard, you get it, say, Micro Center, Best Buy, Amazon, whatever. Intel is on the hook for the warranty on that CPU. And they're not responsible for what the motherboard's doing, or at least right now they're on the hook for it because of all the issues of 13th and 14th gen. But to make sure that the ecosystem is working as expected, then they're the ones that absorb the warranty when it comes to the CPU. So you put together your own.
And the only warranty that Intel put in place is for boxed processors. So if you bought it from a retail store, an actual CPU, they were not given warranties for the OEM's computer CPU. So, like Acer and all that, Dell and all that, all their pre-built systems, you didn't have a warranty on that. You'd have to go to them to get your warranty for that and or a replacement.
Systems, in my opinion, worth it because they tend to come with a pretty hefty premium in price. There is a different kind of a relationship happening there than they are with, say, the board vendors. The last drawback I want to talk about, though, with that is the fact that just like I was getting emails with the failed 13th or 14th gen CPUs, MSI and Asus came out with the first microcode fixes before everyone else, and then more came in. There was like 3 or 4 different BIOS with microcode fixes that took time. I think the most recent one was even
3 or 4. I think there's 3 that I know of for Gigabyte, but there could be other motherboard manufacturers with 4 microcode updates.
And I can't use the motherboard manufacturer BIOS because it's a custom BIOS that came from the ODM. So sometimes it takes them longer to get their BIOS updated when something important like this happens. So the drawback there is it could take longer to get those BIOS fixes if something in the future needs to happen. But the last thing I want to talk about here is the fact that Intel has a very uphill battle to earn back the trust. One of the things I said.
And if you have not checked out my videos lately, Intel, NVIDIA, and AMD might be partnering up for Intel's 18A node or the 1.8 nanometer transistor. So just think about that. NVIDIA might want to partner up with Intel. They've already been talking about this, and they might be finalizing a contract here soon about their 18A and 18AP, which is the lower profile 18A node. And also now, I just got a word about 8 hours ago, AMD might partner up with them as well. AMD might partner up with them, which is absolutely insane in my opinion. So if you've not checked out that video, you should definitely check out that video as well about how Intel and NVIDIA might be partnering up, and also AMD, just for the Intel's 18A node or 1.8 nanometer transistor.
And on the meeting was,
and NVIDIA actually wants to help Intel make this 1.8 nanometer transistor even better. Like they want to help Intel with this 18A node or 18AP node. They want to help them make it even better than what they've been doing.
It takes longer to earn back trust than to initially earn trust. So it's easy to initially trust.
Okay, so that is about the end of the video though, but I went over this a long time ago. It's one of the first ones to say this, and then more or less I got this information because I've owned these CPUs and I've had no issues, and I'm going, what's going on with everybody? Then I started putting things to stock settings and started seeing the voltages being way, way too high, and I'm going, yeah, this would degrade your CPU on stock settings. And there's no way that Intel made their CPUs use 1.6 volts to become stable. There's just no way. So I did a bunch of research of my own, and a lot of people at the time were like, man, there's something wrong with you. You don't know what you're talking about and this and that. Well, guess what? I do. I do know what I'm talking about. I do the research. I do my due diligence on getting the information required. And I do so much overclocking, it's not even funny. So I started doing the research on it, and I was like, you know what? It's motherboard manufacturers, it's RAM manufacturers putting these voltages in to get these Intel CPUs stable at the whatever they want. And guess what? It was true. It was true all along. And it sucks being true. It does, because Intel did not need to go through all this headache, and then all of a sudden they have to put in this new parameter of DLVR, and then put in place for motherboard manufacturers saying you're only allowed to do this now. If you go past these kind of parameters that we're giving you from here on out, you will no longer be a maker of motherboards for Intel. They will make sure that they cut the contracts and probably go through a lawsuit with these motherboard manufacturers if they are caught again doing these way above spec voltages and or wattages and going into Intel's third part of their parameter, again, the 511 watts or 496 watt parameter. So again, Intel did not have to do this. Motherboard manufacturers did not have to do this either. It's just they wanted to be the best of the best, and to say that their motherboards are the best for the CPU, even though it was degrading them without you even knowing it until the time of, all of a sudden your CPU didn't work. That's when you knew your CPU was degraded or degrading. Again, it sucks. It sucks that it all happened. And that's going to be it for this video. I just wanted to bring this out again just because of I've been reading so much more information about these partnerships. People wanting to partner up with Intel with their 18A and 18AP node. And I was like, Intel needs a little bit of leniency and a little bit of a back rub after what happened to them, and it wasn't all Intel's fault. And I just wanted to bring that up again, that it was not all Intel's fault. But that's it for this video. If you do like this kind of video, make sure you comment down below. Don't forget to subscribe, and leave a like. Leave a like on the video. I just want to bring out information to people that is true. I do a lot of due diligence on getting the facts required on this from multiple different sources, and or doing it myself. Again, thank you to all my viewers, subscribers, and donors. You guys are helping out this channel greatly. We're just getting better and better every day, and bigger and bigger. If you're not part of the Discord channel, definitely click on the Discord link. If you're not part of the Patreon page, you should definitely take a look at that as well. If you'd like to help out this channel, you can definitely join it. I am a YouTube partner. And if you want to help this channel a different way via PayPal, I do take donations that way as well. So again, thank you all for watching. And as always, don't forget to get her done.